Okay, so here's an equation. 2 cosine squared of x equals 3 sine of x, and we want to find all solutions. Okay. So for this particular problem, we notice that we have something that's quadratic and something that's linear. Cosine squared, quadratic, sine, linear. Which means I'm going to need to change this cosine squared in the quadratic form, if I can, to something involving sine or sine squared. Fortunately for us, recall that the sine squared of x plus the cosine squared of x is our main Pythagorean identity. So that means that 2 times 1 minus sine squared of x must be equal to 3 sine of x. Just using the substitution where I replace cosine squared of x with 1 minus sine squared of x. Hippity hoppity, distributive property, 2 minus 2 sine squared of x equals 3 sine of x. Rearranging my equation, I've got 2 sine squared of x plus 3 sine of x minus 2 is equal to 0. I look to determine if this is factorable, right? And I can set up to see, do I have something that's factorable, right? And if you need, right, if it's easier for you to see, I can say let u equal the sine of x. So there's a substitution. So I've got 2u squared plus 3u minus 2 needs to equal 0. All right. So what would that mean for me? What would that mean for you? All right, so I've got that set up, and I can go through and see, okay, well, if that's going to be the case, right? If that's going to be the case, I can come through and say, well, 2u squared plus 3u minus 2, I'm going to have 2u and u. I'm going to have a plus 2 and a minus 1, and that would take care of my needs. Okay, which would mean that u needs to be 1/2 or u needs to be negative 2. But remember, what was our substitution? Sine of x needs to be 1/2 or sine of x needs to be negative 2. We know that sine of x cannot be negative 2, right? So this would be extraneous. Right? Or we could simply say no solution here. Right? That there is no solution would probably be a better way of saying it. And sine of x is going to be equal to 1/2, right? Always, always, always sketch out quadrant 1 for positive sine, quadrant 2 for positive sine. Reference angle, I know that the reference angle is pi over 6, so that means that x needs to be equal to pi over 6, or x needs to be equal to, if we look to this part, x is equal to pi over 6, or x is going to be equal to 5 pi over 6. Now this does say to find all solutions. This does say to find all solutions, and we can figure this out in a number of ways, right? But one of the ways, we can use our graph to kind of help us. Y equals, set up our two graphs. So we have 2, and then I'm going to put parentheses, my cosine function, close the parentheses correctly, and then I have 3 sine of x. So I want to be careful with those use of parentheses. All right. I want all the solutions, and I should be in radians because it doesn't specify degrees. So I make sure that my mode is in radians. Right. And I could come over and I could say, okay, So that window, let me go from negative 2 pi to 2 pi and just kind of get an idea. And the x scale, let's go ahead and say the x scale is pi over 2. Negative 3 to positive 3 should allow me to see everything. And I'll go ahead and set up the graph. So there's the cosine squared. And notice that it's always positive. And then there is the 3 sine of x. And I noticed that the intersections are going to be based on the period of the sine function. Okay, well, what's the period on the sine function? The time it takes to repeat itself is 2 pi. Cosine squared, its period is clearly pi. Right? But 3 sine x, its period is 2 pi. That's where I see my intersections. So if I want all of my solutions, I'm going to have x equals pi over 6 plus or minus a multiple of my period, or x equals 5 pi over 6 plus or minus a multiple of my period. And once again, where k is an integer, right? And you can write that in words, where you could say k is an integer. Right? So little details on how to solve, and once again, right, just the more practice is going to help you. Okay.